How's everyone doing? All right, a good and a great. Can't argue with that. All right. That's a beautiful, beautiful brown I got going there. Shooting for a gold, but it'll be okay. All right. So hey, everybody. My name's Harrison. That's my big, giant face right there. Probably noticed there's something missing, so I just thought I'd throw in some beard technology right from the get-go there, because that's pretty more our tune. I got my winter coat going here. Sorry, excuse me. All right. So yeah, got my beard technology on, which I thought was a good start for this. But I'm a front-end engineer at Airbnb, and right now that probably makes a little more sense about who I am and why I'm here and what I wanted to talk about today. This is Troy and Abed, good guys. So I work at a place called Airbnb, and Airbnb is a global community marketplace for people that have some spare space, looking for some space, and connecting them together. That's our homepage right there. But the bigger thing about Airbnb is it's about connecting people. So this right here is the most wonderful host I've ever had the opportunity to stay with. This is Catherine. I stayed at her place in Boston, and with two coworkers as well. And she was renting her place out because her dad had gotten ill, and he had had a stroke, and he couldn't support himself anymore. So she moved back in, and they had this gorgeous, like, 4-story home, and they were renting out one of the floors just so they could help pay for their medical bills. And she was above and beyond the nicest person I think maybe I've ever met, and it was just so crazy to meet her through the internet, because it's always weird to meet people through the internet. And she offered to take us grocery shopping 3 times. We kept saying we'd love to go grocery shopping, but we don't cook, so we made it easy on her. But she's so nice. But other than that, you know, it's great about all the people on our site, but it's also kind of a wacky place. We have small homes, so this is a 1 square meter home that you can find in Berlin, Prenzlauer Berg. It goes for a hefty price of $13 per night, but you can move it around anywhere, which is great. I don't know what the laws are for like where you can move it to, but a park seems like a perfect place to just set up a nice little $13 nook. Oh, that's Twitter. All right. But we also have much larger listings as well. So this is a castle that is in the UK that you can rent for $153 a night. And this is great for like weddings and things like that, but we don't have a lot of these, but it's interesting. So we also have tree houses, which are a lot of fun to stay in, and also igloos, which is kind of weird as well. That is a very well-made igloo. I tried to make one once. It did not look that good. But we also have igloos as well. But over the last 4 years, as we've been growing, a lot of things have been happening. This is actually from our infographic of our global growth. But you can see that in 2008, this is San Francisco, sorry. So in 2008, it was very small. There weren't a lot of people that were listing their places. But now in 2012, you can start to make out where streets are. Like you can see Market Street. You can kind of see, I don't know if this is going to work, but you can see where all the hotels are. Like it gets very obvious. Here's the Tenderloin, you know. It's kind of obvious where people aren't renting out places as well as where they are renting out places, which is always kind of interesting. So it's been growing a lot really quickly over the last 4 years, and that's come with a lot of challenges and a lot of interesting things. But I think what's kind of more interesting to get kind of the geeky stuff going, I thought I'd introduce just kind of the Airbnb stack. I don't think a lot of people are familiar with the technology we use. That's the s'mores, just getting smushed. Smushed. Okay, so we use, we're Ruby is on Rails framework, and we use Git for version control, GitHub all the time. Lucene powers our search. We do a lot of like search experiments and stuff like that. We found that Lucene's much more suited for a search like that than something like Thinking Sphinx, which we were on before Lucene. And then the other kind of thing we found when we switched to Lucene was that it's actually a performance increase as well. So if you're doing a lot of search stuff, definitely check out Lucene. There's a lot of cool things going on there. We use Hadoop as our data warehouse, and that's actually what I end up talking to a lot with my job. But so we have Hadoop. It's where we're storing all of our data. We're using Redis as kind of a key value store. Just know it's all in memory, so If you're going to need it, write a job to like back it up because it'll go away at some point. But anyways, we use MySQL as our backend and for our database, and we've been experimenting, playing around with CoffeeScript a lot. 2.5% of our code base right now is CoffeeScript. It's mostly like mobile web, all wish lists, a lot of new features. It's more of the user-facing features because we find that we can move a little bit quicker if we're using CoffeeScript. But it's not a requirement. We don't force anyone to learn CoffeeScript or anything like that. We use Backbone.js as kind of like to structure our app, our client-side code, because what we found is that it's really easy to drop Backbone in and get going if you have existing code already and a bunch of spaghetti and stuff like that, which we had. We had a lot of technical debt. So it was a lot easier to try to like wrangle it in if we had a structure that we kind of could build out from, which is what we got with Backbone. And then we use Sass. We love Sass a lot. And I'm sure you guys, it seems like a lot of talks around Sass, so I'm sure you guys have been hearing a lot about it. So that's what that is. All right. We're also Amazon Web Services. We're one of their bigger users. If they have a feature, we actually use it. This is actually out of date as well. I should throw a beard on it. But really what we're missing as well is a DynamoDB, which we're using kind of less than Redis because it can actually back it up and scale more. But so we use EC2, that's our servers. ELB is load balancing. EMR, that's our Hadoop machines. S3 is our storage. RDS is database. CloudWatch for the metrics on that side. We got Elasticache for managed memcache. It's a lot of soup there, so sorry for that. But anyways, that's what we're using. We're all cloud-based these days, right? All right. So what do I do at Airbnb? I'm on the data infrastructure team. That's what I'm doing right now. And what does that mean? It's a lot of fun to explain that to your parents. So I made this slide for my parents, but I'm just going to show it to you guys as well. There's three kind of things that I work on. That's data collection, it's data visualization, and then the internal tools that kind of surround that ecosystem. Like, what do we use to manage and actually check in that our data collection services are still up and running? How do we know that we're actually getting accurate data all the time? On the data visualization front, it's kind of more of how can I make tools so that people can actually dive into our data and make sense of it. And then internal tools is just kind of a fun way to poke around at our internal systems and like have unique tools for the other engineers on our teams, like giving a bird's eye view into things like that. So that's what a data infrastructure front-end engineer is doing at Airbnb. But I guess what it really means, and the part that I didn't really explain to my parents, is that it's about making decisions based on data when it's possible. And we really think that you should be making your decisions based on data. It's not a crazy thing to say, but that's a pretty hand-wavy slide right there. So I'm going to say, let's make good decisions based on good data. And the smart ones out there are probably like, wow, you just made those words gold and added good in front of them. And I'd say you're right. But really, a good decision is an informed decision, and good data is reliable data. What I mean by reliable data is just that anyone else that comes back and visits your data and runs kind of the same charts and graphs and analysis on your data will more likely get the same results. And yes, sometimes I like to read the words on the slides. A professor once told me it was lazy to like add subtitles to your presentation, but you know, I said it was great for when the audio. Yeah. Let's go. So, but seriously, there's two big concerns with, oh, that gold again. Two big concerns with the data infrastructures. The main thing is collecting your data and then communicating that data with decision makers, because everyone knows that we have data, everyone loves that we have data. Then what ends up happening is they're like, tell me, what does this mean? And you're like, give me a couple days. And they're like, no, you need to do it now. And you're like, well, let me build a tool so that I can do that next time you ask. And then they say you don't have enough time. And then you do it anyway. It's a rant. Okay, so collecting data. The thing you need to know about that and why this is becoming bigger and why you hear about like big data and things like that is that storage is cheap. Storage is so cheap now that you can just collect everything you want into like one big place. That's a good thing as you start to grow. So when you start to store everything, what you want to do is you want to make sure that you are actually logging everything. It's really hard to go back and say, I need an answer to this question, but we don't have the data for that. And so then you're like, well, I'll start measuring now, but you can't really backfill in there. So what you need to do is just start logging everything as soon as possible, because who knows what you can do with it. We just have a bunch of data that we don't know what we're going to do with yet. but that's fine, that's okay. And the main thing you're going to be seeing is that you're going to want to be looking at your performance, and you're going to be looking at your metrics and how those play like cross-functionally with each other, because you'll see the guys on the performance team doing crazy things that makes a site way faster, but then you'll see, like, if you're watching some of your business metrics, like who's clicking that buy it button or whatever it happens to be, goes way down. Yeah, the site's a lot faster, but we're not making any money anymore because that broke our button. But you should also have a bunch of tests and things like that for making sure, integration tests to make sure that you can actually click the button, things like that. But these are some of the things that we look at and try to make an effort to analyze. Communicating data with decision makers is really just kind of about considering your audience. This is kind of what the heart of this talk is about. Your audience really is anyone. Like, if you're going to be building tools for people to make decisions based on your data, you really want to make them available for everyone in your company to look into. Provide transparency. Let the data speak for itself, because really that's where the truth is. A lot of people will have opinions about what is better and what's not better. But really, if you can point to a graph, if you've said, I ran the numbers, that usually takes you places. The other thing you want to try to do when you're communicating data is you want to try to tell a story. It's the same way with when you're building a user interface or structuring the layout of your site. You want to make the same kind of decisions that you normally would. You want like a login button, you want a log out button, but you don't show those once you're logged in. You switch them and things like that. And then you want to build the tool that ends up replacing you. So right now, that's what I'm doing. I'm building the tool that's going to be a better me. That ends up what happens. So what I want to start with is a really interesting story. And it's basically a data visualization with words. And this story goes way back to the 19th century, and it's about a woman, kind of a hero of mine, Florence Nightingale. Oh, no. Here we go. Just drag that out. There we go. You can't read that at all. So anyways, Florence Nightingale, she was born in 1820, lived till 1910, but she's a big deal. A lot of people don't know about her, but she basically ushered in modern-day nursing practices. She's the one that cared about hygiene and sanitization and things like that. So she was a nurse, and she was also a statistician, which was kind of odd at that time for a person like her. And one of the first big things she did was she went off to the Crimean war hospitals, which was during the Crimean War, which was in Turkey. She went to the hospitals there, which were more of like a makeshift hospital, and she started noticing just the worst things ever. She started to see there was lack of fresh air and light, there was overcrowding, there's lack of food, there's no sanitization facilities and things like this. But really, when you start to notice things like this, and this happens with your data, is that you can't really convey the same story to people. You can tell people the story, but they're not going to get the impact without having been there, right? So really what you want to try to do is extract things from that. So being the statistician, she kind of flipped a switch, and she started collecting data about this stuff. She started writing down everything about the conditions, how many rats were in the hallway, how many dead bodies were just stacked up outside. And she started to write down the cause of death. Before, they would just kind of say, oh, this guy passed away from malnutrition, and they'd cover him up, but no one wrote it down. So then she started writing it down and trying to see what she could get out of it. So she ended up with this just giant table of all this cool stuff. But, you know, not as pretty, because they didn't have that kind of stuff back then. Oh, right. So that was good. Yep. All right, here we go. So what she ended up realizing from the data, just kind of looking at it and trying to extract things out, that more people were dying from preventable causes, like things they could have done to stop them from dying, than on the battlefield. Like when they came in, they were dying from just poor hygiene and like disease and things like that, things they could have prevented. They were dying because they went to the hospital, not because they were at war, which is just a terrible thing for a nurse to watch like her soldiers go on and die. So she started to just try to tell everyone. She's like, I have this data, just look at this, I can prove it. And she just tried to tell everyone. So, you know, she's throwing her note into the ocean, just trying to get anyone to listen. But, you know, it's really hard to get people to listen to you when there's a war going on, because there's a lot of crazy stuff happening. So the big thing for her was she eventually got an audience with the queen. She talked her way up to the queen. But the bigger problem that came up for her was that, how do you convince someone who has little or no statistical knowledge that this is right? Or how do you convince someone with a graph what it means? And so she wrote to one of her mentor, who was the guy that invented the pie chart and the bar graph. She wrote to him, and she was like, how do I convince the queen that we can prevent a lot of soldiers from dying. And her mentor wrote back. He wrote back, he's like, you need to show the queen every piece of data. You need to have graphs everywhere. Make a big report for her. Convince her that you're the expert, and then she will believe what you said, what you say. And Florence, being kind of the, you know, the badass that she was like, no, I want the queen to come to this decision. I want her to realize that this is a problem. So what Florence did, which is pretty funny, is, well, okay, there's that again, don't do that. She invented a visualization. She invented a whole new chart that had never been seen before. And the way she did that was this. This is called a Coxcomb plot. I have a hard time saying that because I kind of stutter on it. So Coxcomb plot. But what it is a pie chart broken up into 12 separate segments. Each segment is a different month in the year. And the one on the left is actually where she started taking, wow, oh my God, where she started taking data. And the one on the left is going to be the next year. So you can kind of see it changing seasonally, going clockwise. You know, August into the flu seasons where it gets really big. And the blue is where people are dying because of preventable causes. And you can see, if you compare December to the next year, you can see that the blue's gone way down. Like they made a decision to finally fix things. But, so this was this new plot. And this was the plot that actually convinced the queen that they needed to do something about that. And she just invented this graph. And the funny thing about this graph is there's no numbers on it. Like, you don't need to know the values. You don't need to know the percentage. You don't need to know how many people actually died, what these numbers are. You just can see that something's happening, and that happens during these months, and that it's out of proportion, that more people are passing away than should be. And the way those segments work, and that's really hard to read, I apologize, is that the area is the number of deaths overall, and that's calculated using r squared pi sine theta, where theta is just the angle that that segment's making. But the interesting part is, why did she choose to use the area as the number of deaths? Well, if you look at it, you can't really use the radius, right? Because what ends up happening is this guy. You start to square the radius. And what happens there? Let's say, you know, the next radius is 2 times bigger than the last radius. What happens there? Well, you're going to square that. So you end up getting a 4 times. It's called a quadratic growth. And that's actually a problem, because it's no longer truthful data. It's an exaggerated data. And so, yeah, it'll seem cooler. It'll seem like there's a bigger problem. But really, it's not to the true facts. So Florence ended up actually realizing this, because she had done it using the radius originally, changing the radius based on the number of deaths. And she had to go back and update her graphs, because she knew a lot about maths and things like that. So she went back and was like, I need to correct this. And that's why Florence is really cool. So going back to the Coxcomb plot, you can see that on the left, this is the same data. This is just a different visualization. If you compare it with a bar chart, what are we really seeing? If you look at the bar chart, you have to really analyze what's going on here. There's a lot of clutter. There's a lot of valuable information here. But if you're not diving deep into how many people are passing away every month, you don't really, the data doesn't really matter as much. And the other thing you're going to notice is you don't see seasonality. You don't see the same patterns occurring the next month or the next year. So if you look at the big spike in the middle, that's January there, that's huge. And then if you look at the next January, where it goes MAM-J, you'll see, yeah, it's big again, but that's what happens in January. But you're not going to see that unless you start to look at it in a deep way. And I think if you presented this to the queen, it wouldn't have gone anywhere. But you know, there are some other really important visualizations that go into the history of when you're deciding how you display your data. And some big decisions have already happened from these kind of things. So this is John Snow's dot map. There was a giant London epidemic in 1854 where cholera, there was a big epidemic of cholera. And what John Snow did, being a physician, was he went around and he asked everyone, you know, that had cholera, and he went down and put it on a map, put a little dot map. And you start to notice clustering, which is kind of hard to see here, but right around here, these black dots, that's where all the cases of cholera were breaking out. And you can actually see it occurring on the same street, on Broad Street. And John Snow started to investigate this because no one else was checking it out. And he's like, what's consistent across everyone on Broad Street? Well, it turns out that everyone's sharing the same water from the same water company. And he went and followed the water line, and it turns out the water company was just ditching in the sewage water from down the harbor, and there's a lot of disease, a lot of bad things that were in the sewage water they're dumping off. So you can't just go to the water company and say, hey, stop serving your water, you're killing everyone. What he did is he went to the local council with his dot map, and he says, hey, look at this. This is in the water. This is coming from the sewage. This is a problem. And they're like, okay, let's go remove the handles from the water pump so no one can pump water anymore. And that's what they did. They just removed the water pump handles, and the outbreak stopped. There was no more new cholera cases since. It's kind of a weird story from just a simple map. And Jon Snow, good guy. And coming back to the infographic from before, it's kind of a similar pattern. Like, how can you cluster data around it to analyze that and see common patterns, like finding out where people aren't going or aren't listing their space? This map right here was deemed one of the most important graphics ever created by Edward Tufte, who's kind of been called a big deal in this area. But what this map right here is showing is that it is Napoleon's march into Russia in 1812. And at each point, it's a different location on their march. You can see how many people in their army were still alive at that point. So you can see it start to dwindle as they get further and further into Russia. And then you can see on the retreat, the black line there, as it's coming back, how the weather starts to come into play. Like, as it got colder and colder, more and more people are dropping off. And this really just kind of, in one quick graphic, you can see why Napoleon failed and where he failed explicitly. And, whoa. The place where you see this kind of map, which ends up getting called a Sankey diagram, is when you're checking out your user flow. And this is an example from Google Analytics, but we have our own kind of user flow diagrams going on right now. You can see where people are falling off, where they're going to, and connecting the patterns from there. And that's just by tracking where your users are going and what they're doing, and trying to figure out where they're falling off and things like that. That's where these diagrams become very useful. The point I wanted to try to make here was that this is important because the way you communicate your data really matters. And it really matters to the people making decisions, and it really matters to just your company as a whole in terms of transparency. So the tool I'm working on right now, we've called it Newton, and what it's going to be doing is we have data in all these different places. Our Hadoop machines, our Flog system. We have data in just a bunch of different places, and everyone's running different experiments on different things, like what's a better color button, what's a better search rank algorithm, and things like this. But what we're finding is that everyone is running their tests independent of each other. Like, there's no consistency, so that the way someone measures a better button isn't the same way as someone else somewhere is measuring what's a better button. So we want to build a tool where we can put all of our data in one place, don't know what it's going to be or how we should analyze it, and generate the graphs that our producers or the people looking into the data need to make the answers and decisions that they can. So I wanted to show you guys this is really rough prototype what we have right here, but so this is Newton. This is built with Ember and D3.js. We decided to go with Ember. Well, I decided to try it with Ember just because Ember is really nice if you can just start new. It's really easy to kind of figure out the way they do things if you can start fresh on a new project, and I saw this as like a fresh project that I wanted to try it out with. The other big thing is you get computed properties and binding data both ways and things like that, which is great when you start to interact with graphs and different forms of graphs. And the difficulty with this kind of project is that this navigator over here, it's not going to know what projects we have until the data shows up. It's not going to know how many children each one of these projects has, or if there's sub-projects inside of there and things like that. And Ember is a great way to structure your UI around things like this. So this is just dummy data that I just threw together for this, but it's a quick way to just kind of interact with your graphs and try to understand what's actually going on if you can compare things on a singular level and interact with them more than just the standard Excel spreadsheet that you know, our lovely analytics team kind of shows everyone every once in a while. We do other things. This is just a dummy there as well, but you know, you can see with a interactive Sankey diagram, you can do neat things like figure out overlapping lays and like where things go wrong and things like that as well. So the big thing coming back to what Newton's going to end up being, hopefully, is that it'll end up being a application where anyone with data can dump in their data and be able to browse and analyze and make decisions from it. Hopefully, if we do it right, we'll be open sourcing this, and so anyone can use this as their data analysis tool as well. And that's kind of our big goal there, probably by the end of the year, hopefully, and we'll see what happens there. But with that, I would love to just open up to questions about data, UI, product, anything about Airbnb in general. Thank you, everyone. So I really think that you should focus more on ways that you can understand performance and ways that you can understand like your bottom line, like the metrics that affect where you make money or that are core to your business, if that makes sense. So ideally, what you want to be doing is tracking how users flow through your site, where they fall off, things like that. I mean, that's kind of the big use case there. But you also want to find out like how people interact with it as well. If you can do smaller experiments where some people get a mouse tracking service as well, where they can opt into it and we can track and see where they're falling off and what's wrong there, that's really important as well. But mainly what you want to find out is analyzing the data of people that are signing up but maybe not completing their profile, people that browse different parts of your site but don't actually complete an action, like your problem areas, like why isn't that number higher?